Today's question is square root of 1 plus square root of 1 plus x, that is equal to cube root of x. Here our goal is to find x value. Observe the left hand side. We have a square root and again we have a square root. So first I start with to get rid of this square root. So that's why I am doing square on both sides. Here we have a square and here we have a square root gets cancelled. So we are going to left 1 plus square root of 1 plus x, that is equal to cube root of x whole raised power of 2. On the right hand side we have cube root of x. Suppose if we have a square root of x, we can write in terms of exponential form, that is x raised power of 1 over 2, isn't it? Same like that, if you have a cube root of x, so this one also we can write it as x raised power of 1 over 3. We have cube root of x whole raised power of 2. Cube root of x whole raised power of 2, we can write this as x raised power of 1 over 3 whole raised power of 2. Now it is in the form of a raised power of m whole raised power of n. So we can write this as a raised power of m times n, isn't it? So we can write this as x raised power of 1 over 3 times 2. We can write this as x raised power of 2 over 3. In the left hand side we have 1 plus square root of 1 plus x, that is equal to x raised power of 2 over 3. What we are going to do now? Again we are going to try to get rid of this square root. For that we have to do square on both sides. If we do square on both sides, here again we have to do whole power 2. That time the right hand side it turns into, again it is in the form of a raised power of m whole raised power of n. We can write this as a raised power of m times n, isn't it? So we can write this as 2 over 3 times 2, which is going to be x raised power of 4 over 3. So in the left hand side we have a square root. It is definitely we have to do the square to get rid of the square root. But in the right hand side we are getting x raised power 4 over 3, which is very difficult to solve. That's why I am going to consider this cube root of x as some other variable. Consider cube root of x as some k. If you do square of this, then we are going to get k power 2. The right hand side turns into simply k power 2. Now it is easy to solve. To do square, we have an extra part 1 plus. First you have to remove this one. For that I am going to do minus 1 on both sides. Here plus 1 minus 1 gets cancelled. So what we left 1 plus x, that is equal to k raised power of 2 minus 1. Here I consider cube root of x is k. So cube root of x, we can write this as x raised power of 1 over 3, that is equal to k. Then what is x? If we do whole power 3 on both sides, here 3 and here 3 gets cancelled. So we left x equal to k power 3. So if you right hand side, if you convert in terms of k, the left hand also you have to convert into k. So that's why now we are going to take x as k power 3. So square root of 1 plus k power 3, that is equal to k raised power of 2 minus this one I am going to write 1 raised power of 2, which is same as 1, isn't it? Now do square on both sides. This square and square root gets cancelled. We left only 1 plus k power 3, that is equal to k power 2 minus 1 power 2 whole raised power of 2. Now k power 2 minus 1 power 2, it is in the form of a raised power of 2 minus b raised power of 2. The formula is a plus b times a minus b. So the right hand side we can write it as, our a is k, so just write k, and b is 1, so k plus 1 times k minus 1 whole raised power of, we have 2, so just write 2. The left hand side we have 1 plus k power 3. This one also we can write as 1 power 3, which is same as 1. So in the left hand side also it is in the form of a raised power of 3 plus b raised power of 3, isn't it? The formula is a plus b times a square minus ab plus b square, isn't it? So let's substitute here. Here our a is k and b is 1. So let's write k plus 1 times a square is k square minus ab is k times 1, which is k, plus b square is 1. So that is equal to k plus 1 times k minus 1. It is in the form of ab whole power 2. So we can write this as a power 2 times b power 2. Same like that we can write as k plus 1 whole power 2, then k minus 1 whole power 2. This right hand term we can take it into left hand side. Then it become minus k plus 1 whole square times k minus 1 whole square, that is equal to 0. Here we have a k plus 1 whole square term and here we have a k plus 1. So let's take it as k plus 1 as common. So we left k power 2 minus k plus 1 minus, we are taking common as k plus 1. Here we have a k plus 1 whole power 2. So that's why still we have one k plus 1 term, and then k minus 1 whole power 2. That is equal to 0. Now expand this. What we have? K plus 1 times k minus 1 whole square. So what we have? We have k plus 1 here. First we do k minus 1 whole square. It is in the form of a minus b whole square. So what is the formula? A square minus 2ab plus b square. So let's write. Our a square is k square minus 2ab. ab is k times 1, which is k, plus b square is 1. Now expand all the terms. K times k power 2, which gives k power 3. K times 2k, which gives minus 2k power 2, plus k times 1, which gives k. Now you have to do with plus 1. 1 times k power 2, which gives k power 2, minus 1 times 2k, which gives minus 2k, plus 1 plus 1, which is 1. Here what we have? We have k power 3 minus 2k power 2 plus k power 2, which gives minus k power 2, plus k minus 2k, which gives minus k plus 1. After doing k plus 1 times k minus 1 whole power 2, this is the result. So what we got? K power 3 minus k power 2 minus k plus 1. That is equal to 0. Now open the bracket. K power 2 minus k plus 1. After open the bracket, then we will get minus k power 3, then minus term minus plus k power 2, then again minus term minus plus k, then minus terms plus, which gives minus 1. Here we have k plus 1. That is equal to 0. Now observe, here we have minus k power 3 term. Here we have k power 2 and plus k power 2, which gives 2k power 2. Minus k plus k gets cancelled. Plus 1 minus 1 gets cancelled. So we left only minus k power 3 plus 2k power 2, and starting we have k plus 1. That is equal to 0. From here we can write this as k plus 1 equal to 0. The second term minus k power 3 plus 2k power 2, that is equal to 0. If you take k power 2 as common, what we left? We left minus k plus 2, that is equal to 0. Here we have k plus 1 equal to 0. From here, so if you do both sides minus 1, then here plus 1 minus 1 gets cancelled. So k value is minus 1. K power 2 times minus k plus 2, that is equal to 0. From here we can write this as k power 2 equal to 0 and minus k plus 2 equal to 0. So from here you can say k is 0. From here we can say minus k, that is equal to minus 2. Then k equal to 2. So these are our k values. We consider cube root of x as k. So let's take the cube root of x as k. So from here, cube root of x we can write in terms of exponential, that is 1 over 3, that is equal to k. If you do whole power 3, then we are going to get x. So our goal is to find x value. So that's why we need to convert in terms of x. So our x is k power 3. So x equal to k power 3. First we take k as minus 1. So k power 3 is nothing but minus 1 whole power 3, which is nothing but minus 1. This is one x value. And then, so now you consider k as 0. So k is k power 3. That is 0 power 3, which is 0 only. And then x equal to, now we have to consider k as 2. So that is k power 3, that is 2 power 3, which is nothing but 8. So these are the x values, but we need to check, is this x value satisfied our given equation or not. Let's check it. First we will take x as minus 1. If you substitute here minus 1, that is minus 1. So 1 minus 1, which gives 0. So this term turns into square root of 0, also 0. On the right hand side we have x as minus 1. So left hand side we have square root of 1. On the right hand side we have cube root of minus 1. This cube root of minus 1 we can write, that is minus 1 whole raised to the power of 1 over 3. So square root of 1 is nothing but 1. That is equal to minus 1 whole raised to the power of 1 over 3. We got this, but this is not equal. 1 is not equal to minus 1 whole raised to the power of 1 over 3. X equal to minus 1 is not satisfying the given equation. That's why we are rejecting this solution. Now let's take x as 0. Let's substitute. If you substitute here x as 0, so then you will left 1 plus 0 is 1 only. So let's write only 1. And root 1 is nothing but only 1. So let's write 1 here. Then in the left hand side it become root 2. That is equal to, here we have to substitute x as 0. So then the right hand side turn into 0 raised to power 1 over 3 with nothing but 0. So the right hand is 0, the left hand is root 2, which is not equal. So x equal to 0 also not satisfied our given expression. That's why we are rejecting this. Now let's take x as 8. If you take x as 8, then here you need to write 8. So 8 plus 1, which is 9. So let's write 9. Square root of 9, the value is 3. 1 plus 3 is nothing but 4. So root 4, the value is 2. So left hand side turns into 2. Cube root of 8 we can write as 8 raised to power 1 over 3. This 8 we can write it as 2 raised to power of 3. Here 3 and here 3 gets cancelled. So we left only 2 raised to power of 1. 2 raised to power of 1 is nothing but 2 only. So right hand turns into 2. Left hand side also we have 2. So left hand side equal to right hand side. That means x equal to 8 satisfied our given equation. That's why x value is 8 only. I hope you like this content. If you like this content, please support to my channel. Thank you for watching.